Hi, in this topic, we'll be discussing about version control. Hi, in this topic, we'll be discussing about version control using Git. Before we go with the topics, here's the agenda that we are going to cover. We'll be discussing about version control, what is version control, how it is done, what are the types of version control systems, introduction to Git, we will see what is Git and how it helps doing version control. We will see about Git lifecycle, how it manages the things in how many number of cycles, and how the Git works. We will be referring to multiple Git commands and having demo on same. And since we create branches for multiple features, releases, and for multiple developers, so we will be learning about branches, and when the development or a piece of development is completed in particular branch, how the branches can be merged to release a particular software. So what is version control system? Version control is a system that records, manages changes to documents, computer programs, etc. over time. It helps us tracking changes when multiple people work on the same project. So when we say about documents or computer programs, these can be any file. So our version control can track any type of file that is being managed by it. Be it a executable, be it a document, be it a Excel file, or any kind of script. So if you are managing it under version control system, so any changes to a document is version control system responsibility to manage. Before version control system, what were the problem? Like why the need of version control system came into picture. Versioning of documents like we have V1, V2, V3, it was all done manually. We had to name the documents and we had to follow a naming convention in order to keep version included in the file name or document name. That was completely manual task, which was not very standard mechanism. Team collaboration was a time consuming and hectic task because every member of the team was storing the copy of the document, code, file with at their own disk. So collaboration between the teams to manage the documents and collaborate among them was very difficult and time consuming task because everyone having their own copy of information. No easy access to previous versions because we were only just to save storage or due to some other reasons we were just trying to share the latest copy of the document, and due to this previous versions were not stored and even we were overwriting. Sometimes it was like we opened the same document and making the changes inside it. We have suppose we have test.doc in word and we are suppose someone asked to change some make some update in the document. Now what is usual behavior of any administrator or developer? They just open the same document and make the changes, and what happens, the previous writing or previous version or previous content of the document was overwritten. We don't have any track of the we don't have any track of the previous content that was present inside the document. And later if someone says okay the previous version was correct, in that case we were not able to retrieve the previous content of the document. And that was the very big drawback of the system of having manual managing of the versions. Multiple version took a lot of space. Suppose now we don't want to overwrite the same document, we can create a copy. Every time we create a copy or update the document, it is a practice that okay, create a backup of the same document with the date, time, or something. We have done we do usually in time whenever we are taking backup of files, we create a copy of the file with a date, time stamp, and that is again taking space. Suppose you have 1 MB file each and you are creating a copy of that file every time you are making an update to it. So now what happens, 111 MB is getting added, the whole content is getting stored in copies on your file system occupying your disk space. That means most of the copy of the files may be useless. Even we are adding a single line, we are taking a copy of that document, which is not a best practice. And keeping versions of document again was a hectic task and occupying a lot of space on your disk without having any usefulness. So these were some major drawbacks because of which we had to introduce a version control system which can manage our documents, our codes, files more efficiently. So with the introduction of version control system, what were the advantages that we added? The versioning of the documents become automatic. You don't need to keep track of the, don't need to decide the naming convention of the files, how to keep the versioning, how to keep the releases managed. Now it's version control system responsibility to manage the versioning of your code, document or file. Team collaboration is simple. Everybody is maintaining all the documents, codes are getting managed at a central place on a server or a remote that is being stored, that is storing the document remotely. So now these documents are accessible. The latest version of copy or the previous releases all are available to every member of the team, so that team collaboration has become simple. Easy access to previous versions. If we see about any document version control system, so suppose you take this example of Drive or SharePoint, they are also kind of they are working on the same functionality. They also keep track of your versions. If you give them option to keep versioning enabled and you want to keep versioning previous version of document available, you have the facility, and they will keep storing previous version of document also. And they know they do not store the full copy, they store the differential of the versions that you are making changes in the future versions or the new copy of the document. So this is where the copy of previous versions are stored efficiently. You do not need to do anything manually, create copy of the document and then update. It's job of version control system to manage the copy or previous version of the documents in repository. Only modified code is stored across different versions, hence saves storage. As I said, whole copy of the document is not uh, stored on the system now. Whenever you are uploading a new document or new code or changed file, then only differential of the means changes only named as a new version. Rest copy of the or rest the content of the document remains same. Hence, it saves the storage on your drive. The complete copy is not getting created. Only differentials are marked as new versions. So this is how version control helps managing your files, documents, codes, versions efficiently than manual version of the management. So this was all about version control. What is version control? In next topic we will be covering types of version control system. We know the concept, but how to achieve it we'll be discussing in next topic. Hi. So let's see what type of version control system we have in place. There are majorly two categories where we can place our version control systems. One is central, one is distributed. As the name suggests, central will store all your information, all your data at a central place on a remote server, on a remote repository. Every member need to commit, check out or place their recent version of codes in this remote repo only. There is no local copy maintained in this central VCS. While in distributed VCS, we have a remote repository where every member, every developer who is collaborating and contributing to the code will place their final version of copy, or they can even store tentative version of the code as well. But additional to it, there is one additional facility provided to the users, like they can, if they don't want to submit their code on the remote repo and maybe due to various reasons, like it is not finalized, they are making some changes, they want to save some changes temporarily on local file system, then want to place on the remote repo. So they have additional facility of storing the code in local repo as well, means in their local folder. Now this distributed version control system provides facility These local workplaces or local folders have this version control system enabled, and this will keep track of their changes into the code locally, and when they want to sync to the remote server, they can do the push of the code and they can sync their local code to the remote server as well. So now there are two-way staging used here in distributed version control system, where users can maintain their code locally, and when they want, they sync their code to the remote repo so that other users can access the code and collaborate among themselves. So this is how distributed VCS is most favorite among all the users, developers, because they can maintain local as well as remote copy of the code very easily and efficiently. So what is central version control system? Central version control system has one single copy of code in the central server. So code is maintained at central server only. There is no local copy of code maintained. Developer will have to commit their changes in the code to this central server. When they want to commit, they have done the changes, they have to submit commit to the central remote server, and this will be available to all other users for access. Committing a change simply means recording the change in the central system. Once you are done with once developer is done with the changes they are making in the code, they can commit and make available to all users by committing it to the remote server, which is maintaining all the codes. In contrast to it, distributed version control system does not necessarily rely on a central server to store all the versions of a project file. Every developer clones a copy of the main repository on their local system. There is still a remote repository where distributed VCS is maintaining all your code files, but it gives you like a facility. You can download the recent copy from the remote repo and work locally in your own local workspace. So every developer can clone copy of the main repository on their local system. This also copies all the past version of the code on the local system too. Means all previous version history, all commits will be available to the user so that they can use it if they require. Therefore, the developer need not to be connected to the internet to work on the code. This is add-on facility. Like for version control for central systems, you need to be connected to the remote server always in order to publish your changes. But here in distributed version control system, you can commit your local changes in your local copy, and whenever you want to upload your changes to the remote server, you can connect to internet and then upload. So this way you have double two-stage facility available for you, where you can maintain your code efficiently. So there are few examples in this coming slide about central VCS and distributed VCS. So Subversion and Helix Core are the softwares tools that can manage your code in central VCS system. They do not offer you distributed VCS facility. While Perforce, Git and Mercurial are the some example of tools that support distributed VCS facility, out of which Git is more popular. We have other options like Bitbucket and other software as well that give you DVCS facility. So this was all about types of version control system, central and distributed. So next topic we cover introduction to Git, which is a major version control system. So let's meet in next session. Hi, so let's see what is Git, which is a distributed version control system. Among all the available tools to manage your code versions, document versions, Git is the most popular tool among all the distributed VCS tools. We saw Git, Perforce, Mercurial. This is a graph that gives you a comparison of the tools that provide you DVCS, distributed VCS facility. So you can see Git is having a good market share, means almost all of the market share is shared by Git product, Git tool. This is very popular, very much popular among all the developers, collaborators, and it is also, there is one more reason why Git is very much popular, because it offers easy integratability with all the softwares that we have in the market. Git can be easily integrated with various other softwares like Jira, Confluence. You can integrate this software with those tools very easily by using Git plugin. Even you can integrate with you can install, you can use Git desktop. So lots of facilities provided by Git that make it very much popular among all the collaborators. That's why there are many reasons why Git is having good market share as compared to its competitors. So what is Git? Git is a version control system for tracking changes in computer files and coordinating work on those files among multiple people. It is primarily used for source code management as a SCM tool in software development, but it can be used to track changes in files for any type of files we have. Any type of document we can store in Git. So that's why where you see, if you go and explore the web, you will see lot of options, lot of collaborators are preferring this Git to store. If you go and log into github.com, you will see lots of repositories and code available here. I will just give you one example. So this is if you want to see Git repository, this is GitHub where you can maintain your code remotely. So this GitHub is a open source software available that's where you can manage, you can upload your Git managed codes very easily and maintain them, and you can share among all the collaborators if you make it public. You can even create your private repositories as well on GitHub. That's where you can maintain your code and you can share with the people with secure access in secure manner only. So both the options are available. You want to share your code publicly with all the people over the world, or if you want to share secretly with only specified people, that can also do with the GitHub. So I have an account, let me sign in. So this is GitHub client. That is a web version of client. That's where you can log in and you can create your account as well. We'll be learning in the coming slides. And this is where you can maintain your repositories. So that's where you see I have stored kind of lots of files. Even if I want to track my trainings, I want to track my any Excel files, any documents, any folder on the system, I want to keep a backup, I can track those files as well on Git. This is not necessary to be a developer code. It can be any type of file. So this is all about what is Git. In next topic we cover Git lifecycle. Till then, keep tuned. Bye. Hi. So let's see how Git manages its lifecycle to ensure your versioning of documents. Git lifecycle. Following are the lifecycle stages of files in Git. You got a working directory, you got a staging area, and you commit the changes to get published. So these are three major stages in your Git lifecycle. So let's see what working directory is. The place where you place your project in your local disk, local computer, is your working directory. This is a very common name that we have used at multiple places, like in Java, in Eclipse, in any other developer, Visual Studio Code. And many software use this term like working directory, workspace. So same way, Git is also providing you a Git also refers to any location on your disk where you are placing your files to be managed as a working directory. This project may or may not be tracked by Git. So any folder on a local system, if you want to be tracked by Git, you need to enable the Git there. It will not automatically track all the folders that you have on your local system because that is completely unnecessary, because Git is a place where you want to keep less number of items, just the items that you want to track, not everything that is on your local system. In either case, the directory is called the working directory. The project can be tracked by Git by using command git init. So that's what I said. If you want to track your folder that you need to be managed by Git, you need to initiate this working like the tracking of the folder inside Git by using command git init. You have to fire a command by going to the folder and do git init just to start getting this location tracked by the Git. By doing git init, it automatically creates a hidden folder .git inside your working directory, and where it keeps the tracking details of this folder and while managing it to the Git VCS system. If you want to track these files on remote server. So this is how you can make your local folder a working directory Git enabled. Second stage of your Git lifecycle is staging area. Once we are working in the directory, you go to the working directory, and we have to specify which files you want to track. Even this way Git gives you a facility, like even inside a folder, if you have large files you do not want it tracked, so you can ignore it. So there are two ways. One is you can ignore the file by using .git ignore, by listing them in .git ignore file, that is again provided by Git. And second is you can explicitly add those files using git add command. So these are two ways you can maintain trackability of your files. Means you have choice to track the files without tracking the whole folder. The slide says we do not specify all the files to be tracked in the Git, because some files could be temporary data which is being generated while execution that we don't want to track. To add files in the staging area, we use the command git add. Git add, once you're done, you can give the file name, you can give the current directory, you can give all. If you want to track all, you have option all. Otherwise you can give the file name, or you can track current directory by just giving dot. So once you do git add on the files, these files are staged now. That's why this is called staging area. Means these files are added to the Git tracking. Next stage is commit. You have staged your files. When the files are selected and are ready in staging area by using git add command, they can now be saved in the repo. They are still not saved until you do commit. Saving a file in the repository of Git is known as doing a commit. When we commit a repository in Git, the commit is identified by a commit ID. Whenever you fire git commit command, Git understands that the changes you were making to the files codes are somewhat finalized, and these need to be saved now. So commit is like saving your changes to the repo, and this save is assigned a commit ID that is used to track the versions of the files that you are committing. Okay, so the command for initializing this process is git commit -m comment or message that you want to give. Like, this is my initial commit, first commit, second commit, or suppose you added some features, so you can give comment like git commit -m added front end or added back end, added plugin to the front end UI. So this kind of message you can ensure just to understand later in future. If you see the code, see the commit, you can understand, okay, in this version of code what changes you had made, you can add in the comment message section of the git commit. So these are three major stages of Git lifecycle. That's where Git manages your code or files. So this is a flow diagram, like how you have a program workspace. You used git init, so that just to initialize Git in your working directory, so that you can track your files, and then you used git add to add the to save the files in the working directory for save purpose. Then you used git commit to save these files or commit the changes to the Git repository. Now this is all done, but still everything that you did is in your local computer only, local folder only. Till git commit, it is not going to push any thing on the remote server, right? As I said, distributed version control system actually store the things at two places. First is your local repo, that is your local working directory. Second is remote server, right? So till we fired git init, using git init, we made our local folder git ready, right? Then we made some changes, we added some files, we deleted some files, we made changes to existing files, and then once they are done, I can add those files, or if we can stage those files using git add command by giving the file name, current directory, using dot or all hyphen all. So that will save, that will add those files to the tracking and staging stage, right? Then we want to save the changes now. We are done with the changes. We added those files to tracking using git add. Changes are done now. I want to save these changes. I will fire git commit -m, then comment in double quotes or single quotes, right? So using this, I have saved the changes, but everything is done here in local folder. Nothing is pushed to the remote location. So this part is still missing. So now everything is on local folder. How do we collaborate with the team now? How I can share the knowledge to them that my changes are completed? You can refer my code, or you can integrate. I can how I can inform my team lead my piece of work is done. Now you can use my module to integrate with other modules. So this need to be done. In order to notify the team for collaboration purpose, once the files are committed, they can be pushed to a remote server, remote repository such as GitHub. I shown you GitHub, right? So now you can use git push command. Git push remote branch name where you want to push. So this you need to give, and your codes will be available to the remote server. That can be GitHub, public GitHub, or you can set up your own local GitHub also in your local network, office network or company network that is not accessible to the outside world. So the GitHub that I shown you here is public GitHub hosted by it is an open source GitHub software that is accessible publicly to all the users over the internet. But same GitHub softwares can be installed locally in your private network so that others cannot access the code or things stored on your GitHub account, GitHub server. So this is how, using git push, you can make your codes available to the remote server or remote repository like GitHub, right? So this is how, once you push the changes to the server, your code is available to all the team members to access. So this was all about Git lifecycle. Next we will see how this Git software works, and we'll discuss about the same. Then thank you, bye. Hi. So let's see, how does Git work? What mechanism it follows to manage your code and versioning. Any project which is saved on Git is saved using a commit that we discussed already in the previous session. So this commit is identified by using a commit ID. Every time you commit with some comment or message, Git actually assigns a commit ID to it. What is the purpose of this ID? This ID is actually used to manage versioning of your code. Also, if you want to restore previous version, previous commit of the code, then you can use this ID by using git revert to revert your code to previous version of the content. So that is the purpose of assigning a commit ID. You can say a version also to it. So this is your project folder. Once you committed using git commit, a commit ID is assigned. Say 00001. When we edit the project or add any new functionality, any changes you make to the new to the code is again committed. You have to commit it to make the changes saved in the system, in the Git, right? So whenever, as I said, whenever you perform a commit, if there is a change, a new commit ID will be assigned to the modified project. The older code is stored by Git and will be accessible by its assigned commit ID. Right? You got a new commit ID assigned, your head will move to the new commit of the project. We have a git head, okay, that tracks whenever that always points to the latest commit. Whenever you want to revert, you need to revert your head, you need to point your head to the previous commit ID. So this is how Git works actually. So whenever a new commit ID is assigned, Git will store the previous commit ID also in order to keep the versioning maintained. All these commits are bound to a branch, right? As I said, any developer need to work in a branch. By default, a master branch is created. Any new commit made will be added to this branch. A branch always points to the latest commit. That is called head. The pointer to the latest commit is known as head, which will always point to the latest commit. If you want to revert, you need to repoint to the previous commit ID of the code. So branch is something like every member, if you want, every member can work in the same branch, but that is not the purpose of Git. It's always preferred that every developer have their own branch, they make their changes and then commit to the same branch until they want to merge it. Okay, all pieces, all testing are done in the local branches of the developers and the testers, and once they are tested, then we always prefer to merge the codes for integration testing purpose later on. The default branch in a Git repository is called master. So if you are not creating any new branch, you can always work in master branch, do your changes and commit them. But why do we need a branch? Say a developer has been assigned enhance this code by adding feature A. The code is assigned to this developer in a separate branch feature A. Okay. Now this developer is assigned a separate task that should not affect any existing code, maybe in master or any other branch. Okay. By default, master branch or production branch will be used to store the final version of the code. So any addition, any changes, we don't want to abrupt the existing version of the code. In this way, the developer that is assigned to add develop a new feature A can create a new branch so that the changes to that he makes do not disturb the existing running version of the code, right? So he will create a new branch out of the existing master branch. This is done so that master contains only the code which is finished, finalized and is on production, right? So he can create a new branch from the existing master branch and start working on the changes that he has been assigned, right? That makes sense also. Everything should be segregated, should not the current changes should not interrupt or disturb the existing running version of the code. Therefore, no matter how many commits are made by this developer on feature A branch, it will not affect the master branch. All the commits, all the push he made will be stored on feature A branch only by this developer, and that's where our master branch code will remain safe, right? So once the code is finished, tested and ready, we can merge the feature A branch with the master branch. When we are sure this product is ready, this feature is ready to be published to the production branch, so that we can release to the customers, then we decide, after all integration testing, regression testing, everything are done, then we merge the code. Merging is the process in Git to merge your code from one branch to other branch, right? So this is where you can see you pulled the code to a new branch. Once your features development are done, tested well, working fine, you merge the code again to master branch, which is having a production ready code. So this was a glimpse how does Git works and how it manages your code in branches and segregate the changes without impacting the production ready code until tested well. So next we discuss and see a demo around how some Git commands can be used to manage our work. The same that we have discussed till now, we will see in working. Till then, keep tuned. Bye. Hi. So let's see some git commands in working. So far we have discussed about various things like git init, git add, git commit, git push. So all things we will see in working now. So you can do following tasks when working with git. So we will explore commands related to below task, creating repo. From our local folder we will create a working directory that will be git initialized. We will make changes, we add or delete files, we make some changes to the files and get them staged to the git and push them to the GitHub server. That will be like we'll see in syncing repositories and we will see branches, how can we can create branches for parallel development. So let's create one directory in our local folder. Before that I need a Linux server. You can do that on Windows machine, you can do your laptop also, you can have your own server. I will be using my Google Cloud instance. Linux instance I will launch for Ubuntu and that will have automatically git installed that I'll be used for this demo. Let's give a name to this server like git demo and select the type of the server. I will use N1 because I do not need any heavy requirement or a heavy load on this server, and I can change my flavor of OS from here to Ubuntu so that I can launch Ubuntu machine. I can select Ubuntu 18. The default size I will use 10 GB disk allocated to the server that I am creating. Let's click create and once the server is ready I can start showing you this the demo commands in working. It will not take more than a minute. So let's go back to the slide. First thing we will be checking here how we can create a repository. Okay, and as I said, our working directory will be our local repo that we can sync with the repository on GitHub. Okay. So let me check. Yes, my server is ready. One good thing about Google Cloud platform is you can do SSH on your web browser itself. You do not need any SSH client or anything to log into the server. Okay, so my server is ready. I am logging into it. Let's check if Git is available here. Yes, so Git is available. You can check the version also. Git 2.17 is installed. So first thing was let's create our working directory. So I can do this using mkdir, that is the Linux command, and give name to my local repo working folder as git demo. Right? So git demo is ready, is created. I can go inside it using cd and see there's nothing. Even I can check for hidden folders, hidden directory as well. And I using ltr a is used for listing hidden folders that starts with dot, hidden folders and files both in Linux. You can see I don't have anything. Let's do git init. Why we do git init? To make our local folder working directory tracked by the git initialized, that means. So what I did git init and you can see git directory is initialized inside home, my home folder, git demo. Okay, and you can see a .git folder has been created now here. A .git folder is created. If you list, you will see many information related to git here. See info, description, reference, object, hooks, config, branches that we have, head where head is pointing. So you can see a lot of information inside git. See, so here if I checked for head, my head is pointing to the master branch, right? Whenever you change the branch, your head point to that branch only. So now we have successfully initialized the git. What is next task? We will make the changes, right? So in order to track any changes, in order to see any changes in your repo, there's a command git status. You can use git status to see if there are any changes in your repo on local repo. So it says on branch master there's no commit yet. If you are making any commit, any changes, it will show you nothing to commit, right? So let's add two files. Touch, I will use touch command just to create file 1.txt. and let's create another file, touch file2.txt. Again, do ls-ltr. Now I can see my working directory has two files that I just created. Let's fire the git status command again. What I can see the message here in git status, because I have not made any commit, I have not run the git commit command yet, so it is saying no commit yet. There is no staged file also, because I have not fired git add command also. That's why it is not showing any tracked files. It is what it is showing, untracked files. Until you stage any file in the git using git add command, everything that you add to the working directory will be untracked, will be listed under untracked. So both the files that I added here are yet untracked, right? So what we can do, I can stage these files now using git add command. Everything I have here is in my current folder, so I will place dot refers to the current folder. So everything in my current folder I am going to commit. Okay, it will not track your local your hidden folders. When I say I am going to track everything inside my current working directory, that doesn't mean it will track hidden folder. Hidden folder will always be excluded. So that's where .git folder will always be excluded from the changes that I am committing or adding to the git. So I did git add dot, right? Let's run the git status again. What you see now, message has changed, right? Again, there is no commit because I have not run the git commit command yet, but changes to be committed. Now message has changed from untracked to the changes to be committed. Now that means these files are staged, right? Even if I have added these these files to my git tracking by mistake, I want to remove them later on. So it is suggesting if you want to unstage these files, you can use git rm -- cache and then file them. So if I don't want to commit these files later on, I have decided like before committing I want to remove these files, I can remove them from the tracking. So removing from tracking staging, that doesn't mean file will be deleted. File will still exist, but they will not be part of git tracking. That is all. So git status shows my files are staged now. What next? I want to save these files. My changes are complete. I have done making changes to the file 1 and file 2. Now I want to save these files and commit them. What I can do, I can run git commit command -m with the message like it is my first commit. Right? So let's run it. Now it gives you a good message. Please tell who you are. Before committing, I need to, the changes are committed, okay, but I have not added anything like which user I want to add, which user I want to commit, how I want to, where I want to, if later I want to push these files, where I can push these files, right? So these all things I need to tell my git repo. So I can do this by adding my email and GitHub account. For that, you can also create your Git account just by going to GitHub, right? So before that, let me show you if they are staged or not. So if they are committed or not. Git status will show you changes still not committed because git config is not done on the account. So let me run git config. Before that, I will tell you how you can create your own account. You can you can go to github.com. Open a private browser. Github.com, you can go and you can sign up. If you don't have your GitHub account yet, you select a username, you give a name, select a password, and create an account. This is how you can create account. It will again ask you some puzzle to verify your account. It will once you have created your account, it will give you an email on your email ID to just verify the email address that you have entered. Right? So this is how you can create your you can create your GitHub account, and that will be your remote server for distributed VCs. Okay, I have already one, so I will add my account here. Git config is the command hyphen global user email. I will add my email here. Similarly, I can add my user here, user.name. Okay, so this is what I have added. Now if I run git commit, that should run successfully. See, I was able to run my git commit command here, and I can see two files changed, 0 insertions, 0 deletions, and now these two files are in create mode. They are created in git account. Okay, so if I fire git status now, I should see a different message. Now there is nothing to commit. All changes that I did into my working directory are saved to the git. Right. So this is how I have done making changes, and this syncing of repository has need to be done. So for that I have already added my files to the git repo and local git repo, and commit is done. So till this we are done successfully. So now what I need to do, I need to create one remote repo. So let's go and create here a new repo. I can call it git demo, right? Git demo is available and I can make it public as of now because I don't want to restrict it. Just create repository, and this repository is ready. You can add this repo. There is no content, right? If you go and see, this is just started. There is no code. This is a blank repository. These are some commands. It will give you all references that you can use as a new user to start with. This is the URL of my git repo. So what next? How I can let my local working directory know where my git repo is using git remote add command. Okay, so git remote add origin will actually add your remote server remote git repo to your local account. So now using this, my remote server remote GitHub account has been added to my local working directory. Correct. So now I can push. If I do push, I want to publish the changes on my remote branch, remote repo. I can use git push. And what it says, the current branch master has no upstream. The push to push the current branch and set to remote as upstream, use git push -- set is upstream origin master. Okay. What I can do, I can use git push, and I have to specify the branch, which branch I need to put. This will actually push to the remote branch. So pushing to the remote server, I need to configure my user. That already done. Now I need to provide credential, because just knowing my address, my branch address, my repo address, no one can publish or push anything directly to my branch. That is why Git keeps your repos secure. So before submitting anything, before pushing any changes to the to my GitHub account, to my GitHub repo, I need to authenticate myself. So I will enter my username, and I need to give my password to publish the changes. You can see changes are successfully published. 3 objects pushed successfully to my remote repo. So this is how remote syncing is done, right? This part we have successfully completed. We should be able to see the changes on my, if I refresh this repo again, you see there are 2 files that I created in my local working directory are available on remote repository as well, right? So this is what about syncing the repositories. We have successfully synced the repositories, and now the next thing is the clone. We can even clone the, suppose I have this repo available and some other user, like for parallel development, some other developer want to access my changes. What he can do, he can just go here, clone code, and copy this URL. I will just change my directory. Let's go here, and I will come to my home directory again. I will create one more directory here, mkdir clone repo status here, and you can see it is already initialized, branch is up to date, and nothing to clean. Suppose I go in my previous, I become a first developer, and I go to my git demo folder that I created. git underscore demo, right? And I add a third file, git fetch file3.txt. Okay, I need to again do git add dot git commit second commit. Okay, and do push. Sorry. Okay. Correct. So the first developer has made the changes, and I can go again to the second developer. Now I have become a second developer in git demo folder. I will not see the third file. What I can do, I can pull. I can pull the changes from this branch again. Copy. Okay. And what it will do, you can read the message. Total 2. Okay. And what did files 3.txt has been added to this folder. Only one file changed. That's the new one that I added. So you can see third file also available. So any difference in the changes, latest changes, you will not do git clone. You will go with the git pull command to pull the recent changes by the other developers, right? Third is git branch. So until now we worked on the master branch. We saw how you can work on Git, but now imagine multiple developers working on the same project or repository. To handle the workspace of multiple developers, we use branches. Branches actually partition the repo into multiple workspaces where each developer gets their own place to work and make their changes. To create a branch, as we saw, we already have a master branch that is already provided by Git to work upon. But based on the requirement, parallel development needs multiple branches for every developer to work upon. Based on and branches does not depend on developers only. They depends on the requirement. You may have, if you are working on feature, you may have feature branch, you may have testing branch, you may have production branch, release branch, hotfix branch. These kind of different purpose branches also serve. So creating branches inside your repo is very simple. You can use just git branch command and provide the branch name. Similarly, you can delete any branch by just giving with the -D option. Okay. So I can create, let me go with the first developer. I have become a first developer now, and I will create a branch here now. Git branch, say user1. Or I can create feature A branch, right? As we discussed in the slide. Feature A. Okay, so this way I have created one branch here. Okay, and I can so when I do, if I want to list my branches, I can just run git branch. It will show me all the branches, and here you can see star means currently I am pointing to master branch. But what if I want to change my branch to feature A? There is a command for this. I can use git checkout feature A, and now it says switch to branch feature A. If I check again, my star will point to feature A. That means feature is A is my default branch. What does this mean? This means any changes I publish will go to feature A rather than master branch. This is how my changes now, which I do in feature A branch, will not impact master branch. Correct. So whatever things we do, Git tracks them. Okay, and how we can check those tracking, recent tracking in the repo using git log command. All logs that are stored can be checked using git log command. If you see here, I just run this git log command, and it will show my recent commit ID. This is a hexadecimal string that you can see here as commit ID, and it will again show where my head is pointing. It is pointing to feature A branch. Origin master branch is not getting pointed, right? Origin master remains with the master, but head is pointing to feature A. Author is this, and we got all commits will list here. This was the first commit with commit ID this, and second commit that I did is commit ID this. This is how git log maintains all the history that you have maintained. Okay. So similarly, so we saw lots of command here. One more command that is important. Suppose you don't want to publish the changes to the remote server, but temporarily you want to save those changes in your local branch. We know that we have a Git, but we don't want to commit those changes. Rather, we want to temporarily save those changes until we are working on some other branch or other requirement. So want to save your work without committing the code. Git has got you covered. This can be helpful when you want to switch branches but do not want to save your work to your Git repo. Okay? You do not want to get the changes saved to the Git, just temporarily you want to save for some other reasons. To stash your staged files without committing, just type in git stash. So git stash actually will save all the work that you have recently done after previous commit into some temporary manner that you can later retrieve if you want to come back to work again in the same branch. Okay, if you want to untrack file again from the git stash, you can run git stash -u command. Okay, so that means uh, git stash and git stash -u both serve different purpose. Git stash -u means it tracks only untracked files. That means you do not need to do git add command. Okay, git add is done. That means your files are tracked. But if you want to track those files also which are not staged using git add command, you can use git stash -u, and this way it will track your your unstaged file also. That's why we are using -u option. So suppose once you are back to the work and want to retrieve the working, you can use git stash pop command just to get your work available, saved work available again. Later you can decide whether you want to commit or delete those changes. How we can do it? So similar, suppose I added a file here. Okay. I add a fourth file here, touch file code.txt, and I have not added it. What I just want to stash these files. This is untracked, right? Git stash. If I do git status, what it will do? It says my file 4 is untracked. What if I want to stash it now? I need to use git stash -u option. You see saved working directory and index state work in progress on feature A. Okay, so this is a second commit ID. That on top of it has saved it. I can change my branch. I can go to another repo. I can do some work and I can come back here again. Right? I came back again. I can do git stash. Even after git stash, you can check the status. That is again interesting. You see, your changes are saved. It is not showing you untracked file. The file is stashed, and after doing git stash, it is not showing any untracked file for you. What if I do git stash? Once again, it will show me one untracked file that I can add or delete as per my requirement. Okay, suppose I want to revert to the previous commit. The recent changes that I did, the second commit if you say I did, is not required now. I can revert also. But how we can do it? Git provide me a command to revert my changes to previous commit using git revert. So I need to retrieve the commit ID in order to revert to the previous commit. What I can do? I can copy the previous commit ID. I can do git revert and commit ID. What it will do? It will revert me and ask me if I want to put any comment here. No. So I can just save. And what you can see here, whatever new files I added should be deleted now. Right? You see? Sorry. So whatever changes I had done in this commit are reverted now. So the changes that I did in my first commit, I added file 1 and file 2 are removed now. Right? So this is how we can see how I can revert any commit. The changes I did in any commit will be removed. Right? So this is how git revert can be useful, removing the unnecessary changes or commits that I don't want in my product now. So the recent changes that I made in second commit are available. First commit changes are removed. Hope that makes sense, right? Again, suppose I have made some commits changes later on. and I want to check how they are different from the previous commit. Okay, so git provides a very important command. Like this commands help git provides you a command git diff, and this commands help you in checking the differences between two versions of a file. Okay, so suppose I add some content in file 3. My both files are blank, right? So I can open my file 3.txt and add some content. Hello. I can do git diff and the second commit that I have already. First commit is reverted, so it will give me what changes I have made from the previous commit, the commit that I had, and the content that I have in my recent folder. The recent folder content is not committed, but still I can check the difference between the recent data and the previous commit. Right? You can see there is an addition of one line plus hello in this file 3.txt. So it minus 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 means anything if I delete it will be listed here. And minus minus, so I have not deleted anything, so that's why you see nothing after minus 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 files.txt. Again plus 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 means addition, so you see hello is added here, so that's why you see one line here that I added in file3.txt. Okay, so if you want, you can check the git log again to see the changes. Right, my head is here, the recent commit. My master remains here because I did not reverted the master, I reverted the feature A only. So master head remains here, right? And the second commit, and this is my revert of first commit. So that's where you see a new commit ID has been added after reverting the first commit, right? So this is where you see my head has moved for feature A, while for master it remains here only, master branch. And any changes that we make here, if I do a new commit after making the above changes, that will again get recorded in the logs that I can see using git log. Okay, so this was all about the commands that we can use in our in managing our versions of code in using Git. So most of the commands that are very useful and help in managing our code inside Git, we have discussed here, and we have seen the working of them in detail here. Okay, so this is how if we can check other commands as well, how they can be used. So every command has a purpose, and if you know them well, they will help you managing your code versions over Git very easily. So let's cover some more topic in coming sessions. Next sessions that we discuss is merging branches. As I said, if you go here and see, we have created two branches, feature A and master. Both are lying. The head for feature A is lying at this commit, where we reverted our first commit, and while for master it is lying at the second commit only, right? So these all things we if later I want to merge my feature branch with the master branch to merge the changes that I have done, recent changes make available with the master branch, I can use merging of branches that I will be discussing in next session. Till then, keep tuned. Thanks. Bye. Hi. Till now we have learned about various commands used in Git. We have saw why we need branches and when there are multiple branches. So in this session, we will see how we can merge the changes done by various developers in their own branches to the master branch or any other branch. So what is merging branches? Once the developer has finished his code feature on his branch, the code will have to be combined with the master branch so that it can be released to the end users. This can be done in two ways. First is git merge and second is git release. What is git merge? If you want to apply changes from one branch to another branch, you can use merge command. Merge command is used to merge any change from the source branch to the target branch. This should be done and used on remote branches. That means if you want to merge your changes to any remote branch lying on remote repo, then or local repo or remote repo, then you can use git merge branch. This changes when you are doing through git merge will be available to remote branches and can be accessed by the remote users. Since history will not change, so that's why we use it with the remote branches. Creating a new commit, it actually creates a new commit which is a merger of two branches. Whenever you are using git merge to merge two branches, it will create a new commit and you will see a new commit number, new commit ID created in the git log if you want to check that. The command that we can use is git merge and the source branch from where we are borrowing the changes. That means you have, suppose you want to merge the changes from feature A branch to the master branch. You need to check out your master branch and then run the command git merge and feature A branch name. That is the source branch from where you are borrowing the changes, new updated code. Okay. Imagine you have a master branch and a feature branch. Right? The developer has finished his work in the feature A branch and want to merge his work in the master branch so that it can be released to the production. So you can see it from the figure, you can see your master recent development has been done in feature A branch. Similarly, there may be other feature branches or developer branches that may be ahead of the master branch, because master always has a stable code, production ready code that is released to the user. So here from the diagram you can see feature A ahead of the master branch with the recent changes, and that's where these recent changes I want to merge to the master branch. If developer uses git merge, a new commit will be created. You see, this was the old commit where master branch was residing, head was residing. Once I use git merge and merge my feature A branch changes to the master branch, a new commit with the blue circle has been created and all the changes from the feature A branch has been combined to the master branch and they are available for the release to the end user. Any new commits to the feature branch will be isolated from the master branch. So now developer can continue with the development and addition to the feature A branch that will again not impact to the master A branch until they again merge the code to the master branch after testing. Remember and ensure that whenever your code are fully tested, bug free and serving the purpose of the requirement, means fully functional, then only you have to merge the code, bug free code to the master branch. Otherwise you may mess with the production environment. So let's see how you can get the git merge command in working. Let's go to the server. I will create one repo working directory locally. Demo. And here I will initialize the git. To make it git tracked location. Okay. So let me add some files. Touch file1.txt, file2.txt. Okay, and yeah, so let's add two files for now. So these files are untracked. I will add them to stage and then commit them. First commit. Okay, so these are committed now. If I check the status, I will see nothing to commit. And if I check the files, actually the content of the folder, I can see these two files have been created. Let's check the branch also, which branch I am right now. As I have not created any other additional branch, I will see master by default available, where all the work has been saved. Let's create another branch. Branch feature A. Okay. Before moving to feature A, switching to feature A workspace, let's add one more change, one more commit. So let's add one more file. Using touch file 3.txt. I am adding one more file here in my master branch location. Okay, and let me commit it. So git add dot and git commit hyphen m second commit, right? So this is where if I check my git log, I will see 2 commits have been done by me in master branch, right? So this is the first commit that I made, where from where I borrowed my feature A branch, and this is the second commit in master where the head is pointing right now. So these 2 commits are related to the master branch workspace. Let's check out feature A branch. Git check out feature A. Okay, and let's do some work here. I will create 2 more files, or let's create file one by one and commit them. File 4.txt, track it, git add dot git commit hyphen m file 4 created in feature, right? This is the commit. This is committed. Let's check the git log. We can check graphical representation of the log also using file 5 dot txt and track it again. Git add dot file 5 created in feature. Okay. So again I check the git log history. I should see the one more commit added. Now what I have done here, I have done 2 addition of files. I want to merge these changes to the master branch. Suppose my development has been done for this requirement as of now, and I want to merge my branch changes to the master branch to release to the production. Okay, so what I can do, I need to go to the master branch again, git checkout master, and from there I can run git again. I will show you git log first so that we can check the differences later on. So this is the current status of my git log for master branch. Let me do git merge and feature A branch. What is the command? Git merge and the source branch name. Source branch is feature branch from where I am borrowing the changes to master branch. Okay, master branch I am merging from feature A. Run the command and it will ask you to put comment, or by default it will put comment merge branch feature A. So let leave the comment as is because we are merging from feature A. So there is no harm keeping the same comment here. It will record a new commit with this comment merge branch feature A. Let's check the log again. What we can see? See, so now graph is more visible because we have merged the changes from 2 branch, right? So it is tracking, the git log is tracking 2 branches and their merger. From if you see from start, from first commit I originated my feature A branch, right? Where in this feature branch I made 3 commits. If you see here, this was the second commit made in master branch, and then this was the, if you see star here, every star means the commit is referring to the star put on respective branch. So this left branch is master and this branch is your feature A branch. So from here, if you see for first commit, feature branch was created. So you see a branch getting created from here, right? And then second commit was made on master branch. So that's why you see second star in master branch line. Then third commit you see here was made on feature branch where I created file 4. Then again the fourth commit was made in feature branch again where the feature A branch head lies and file 5 was created. Now I came to branch master back and merged the changes from feature A where you can see the branch is again merging to the master branch. So you can see branch originated and the changes merged here with a new commit ID where master head is line with the commit merge branch feature A. This is how git merge works, and you can see the merge changes in graphical view that I already shown you. Next is git rebase. Why we need this git rebase when we already have git merge? This is an alternate to git merge command. Alternate and serves a different purpose. It should be used on local branches. Remember, in git merge we were publishing changes to remote branches, while in this, if you want to merge changes in local branches, then we use git rebase. Since history does change and will be confusing for other members. Suppose we are doing changes in local branches, and history, because your git merge creates a new commit ID, okay, and it does not it actually keep track of all the history that you are working using graphs and all other manners. You commit ID, new commit ID generated, you can track the changes, while git rebase will not keep the history. Okay, so that's why if you want cleaner branches of code, then that's where we use git rebase. Also, git rebase does not create any and results in a cleaner history. Because we are doing changes in my local branches, we are merging in my local branches from feature A to merger to master. That's where I know what I'm doing, so that's where there's no need of tracking lots of history in the git log, and that's where I can use git rebase so that to merge changes in local branches, so that there is a cleaner history available in my log, and when I push those changes to the remote repo, these things that I am doing locally should not be visible to them. While when I want my changes to be visible to the others for pushing to remote branches, then I should be using git merge command. That is the difference between the uses and purpose of using two commands for merger. Okay, the history is based on common commit, because the new commit ID is not created during git rebase. The history is based on the common commit of the two branches. The latest branch, the latest change commit or commit number will be assigned to the merger. Okay, how it happens? The destination branch commit means, suppose I am merging my test branch or feature branch changes to master branch. So master branch is my destination branch. Okay, master branch is my destination branch. This one, this is my master, and this is my feature. Now master's commit is C1 and features commit is C2. So what it will do, it will pull the latest commit of my master branch, which is my destination branch, say C1. Okay, and from its base, the destination master branch commit is pulled from its base. The latest commit C1 will be pulled from my destination master branch, and it will rebased onto the latest commit of the source branch. So latest commit of the source branch is C2. So now it will be rebased with the latest commit of the source branch, that is feature A, I can say in my case. Understand? This is how it works. Imagine you have a master branch and a test branch, or in our case we can say a feature A branch, right? The developer has finished his work in the feature A branch and the master has moved forward. There may be multiple developers working together, right? And they may have merged their recent changes already with the master. And your master head has moved forward while the code was being developed on your feature branch. Now you want to, the code being developed is related to the new commit added in the master. Now you want to merge the changes. Okay, the code that you have merged, you want to the code that you are developing is related to the new commit added to the master. The new changes have already been added to the master. Now therefore you want all the changes from master in your feature branch, right? So master is moved ahead, and where you want these new changes available to the master branch to be merged with the local feature A branch, right? Since it is a local branch, you would want a cleaner or linear history. You decide to use the git rebase. This is somewhat reverse, right? Your master branch has moved ahead and you want to merge the changes from master. You want to borrow changes from master branch, the latest changes that have been done already there by other developers, so that these changes are available to your local branch. So that's where you don't want to populate your git log with a lot of history, and you can use git rebase. You can use git master, sorry, git merge, but since it is available to your local branch, you don't want to do a lot of tracking, history keeping in logs. That's where you can use a cleaner approach of git rebase. So this is the diagram. Your master has moved forward and you want to borrow these changes to your test branch. So this is how output will look. You will check out your destination branch, test or feature A in our case, and you will do rebase from source branch, that is master, which is ahead, having recent development from other developers to pull in your local copy of the code, right? So when the git rebase happens, there will not be any new commit ID generated. The new commit will be borrowed from the latest commit ID of the source repo, source branch. Okay, so the commit was rebased from the first commit to the next commit. So this is how git rebase looks like. You can see test branch has taken the changes from the master branch and has moved ahead as per the latest commit of the master branch. And looking at the history, we can see clearly see it is a clean linear history without any branches. You will not see any branch here when you are using git rebase. There is no any graphical representation like git merge. Okay, this is how git rebase look like. Let's see the same in action. Let me see which branch I am. I am already on master branch. Let's make some changes in master branch. Suppose I am other developer and I am merging my changes to master branch. So I will just create some new files here. Let's see what files I have here. I have 5 files. So let me create one more file. File 6.txt. Let me stage it. Git add commit a relevant message like file 6 created in master. I love you. This is now committed to my master branch. If I check the log using same command, I should see one more commit. Correct? You see, file 6 created in master. And it has been moved to the latest commit. So let me check out. I want these changes to be rebased to my local branch. Correct? So I will check out my feature branch. My local branch is feature A branch. Let's go here and see what files I have. I have only 4 files, right? Master was having 6 files, right? I want rebase those changes here. First let me show you the graphical representation. This is my current history of feature A branch. So let's do git rebase. Remember, the destination branch is feature A, which I already checked out, and I am rebasing from the source branch, which is master in this case. So if you do it, it is already done, right? Let's check the log again. Now here you see a full log has been captured, and don't get by this, because this was the previous merge history, which now reflecting in my feature branch also. Earlier I merged my feature branch from to master branch. That's where I got this graph created. My recent rebase activity has only this entry. So focus on this line. This is the older history borrowed from master, and this is the recent history added here on in feature branch in log, where you can see this destination branch recent commit ID was picked. Okay, and recent changes were picked from master branch, and this was the latest commit in master branch. If you see here, let me show you. This was the latest commit from master branch, and this commit has been rebased on the as the latest commit for this git rebase activity. No new commit ID has been generated. So this is how git rebase works, and you can see a cleaner history. There is no graph or anything created for this record, and we have a cleaner history in terms of logging. This is how Git rebase works. You can have a when you want a cleaner history and you want to merge changes from remote branch to local branch just for your purpose, then you should prefer to use Git rebase for merging branches. So this is all about Git that we had to discuss in this session. So thanks for your attention, and keep tuned for next session that we cover in this training. Till then, thank you. Bye. కుదురుండు అన్నీ ఆ పొలతో కలిస్తే కుదురుండు బాగుండు రెండు వాళ్ళ ఆఫీస్కి వెళ్ళి నేను కొడుకు వెళ్తానండి ప్రాణానికి ఎంత అయిపోయింది అంతా లగ్బర్ అంటున్నారు అల్లుకో ఏంటమ్మా అది ఏం చెప్తా చెప్తుంది చూసా అది ఒక్క నిమిషంలో పట్టేస్తుంది ఏం మాట్లాడుతున్నావు అది కన్నా నువ్వు సినిమా చిన్న